Hello everyone, today we're going to be breaking down how to balance chemical equations in a super simple way. If you've ever felt stuck or confused by these concepts, then don't worry, we will have it all cleared up by the end of the video. In chemistry, reactions always follow the law of conservation of mass, which by the book definition means that mass cannot be created or destroyed. In terms of balancing chemical reactions, it means that both sides of a chemical reaction will always have the same number of atoms. So let's start with a small example problem, just to get our brains working. So we'll start with H2 plus O2 creates H2O. A good strategy that I like to employ is to first divide the whole chemical reaction in half. So we'll have 2 hydrogen atoms on the left side along with 2 oxygen atoms. And on the right side we'll have 2 hydrogen atoms, as shown by this guy right there. And we'll have 1 oxygen atom because there's no coefficient on the bottom of this oxygen. Now to fix this problem, we're going to have to do something with the oxygen because that's the part that's messed up. And many of you might think, oh, I'll just put a 2 on this and then it'll be good. But that's not possible. You can't do that because hydrogen's also attached to the oxygen. So in order to fix this, we're actually going to have to put a 2 on the outside here. And that 2 applies to the oxygen and it also applies to this hydrogen right here. So now what this will look like is you're going to want to multiply each of these atoms by 2. So this will get multiplied by 2, this will get multiplied by 2. Now this will create 4 hydrogen atoms, and this will create 2 oxygen atoms. Now there's an imbalance in the hydrogen. So the oxygen is all good, so this is all good. But now we need to fix the hydrogens. And it looks like there's only 2 on the left side, but there's 4 on the right side. To fix this, we're just going to put a 2 in the hydrogen right there. And that won't affect the O because there's an addition symbol in between the two, separating the hydrogen and the oxygen atoms. Then we'll just we'll multiply the hydrogens by 2, creating 4 hydrogens. And now this would be a balanced chemical equation right here. Moving on to another problem similar to the previous one. Now we'll work with nitrogen plus hydrogen creates NH3 or ammonium. Now to balance this chemical equation, we're going to divide it by that, same way we did with the water problem. We're going to write N creates 2, and then H has 2 as well. And then on the right side, we'll have N equals 1 and H equals 3. Now, go ahead and pause the video right here and try and solve this before I go ahead and solve it for you, and I'll give you a couple seconds. Alright, now that you guys are back, what we're going to do is we're going to start on the right side because that's where we have a deficient nitrogen atom. On the left side we have 2 and on the right side we have 1. So similar to the previous problem, we're going to put a coefficient of 2 on the NH3. This will multiply this by 2 and this will multiply the hydrogens by 2, creating 2 nitrogens and 6 hydrogens. So now this top part is good. And the bottom part, where we have 2 hydrogens and 6 hydrogens, is not good. So we need to now multiply this hydrogen by 3. So 3 times 2 will equal 6. And that would be considered the balanced chemical equation. So now that we finished 2 semi-easy problems, let's move into more complex problems. We'll do one looking like this. This is iron plus O2 creates Fe2O3. Let's start again by doing our strategy of dividing the chemical equation in half, and we'll just write how many atoms we have. So Fe equals 1, O equals 2, Fe equals 2, and O equals 3. Go ahead and pause the video again and try and solve this, and then you can come back. This is a little harder one, so feel free to just keep watching. Alright, now that you guys are back, we'll go ahead and solve this. So right away, I notice, okay, we have a deficient on both sides with the iron and the oxygen, compared to the iron and the oxygen on the right side. So to fix this, we'll immediately put a 2 on this iron to multiply this by 2, making that balanced. And then it looks like we're going to have an O2 here and an O3 on the right side. So what you can't do is you can't do fractions because that won't be good. And you want a balanced chemical equation. And balanced chemical equations always have whole numbers on the left side of the atoms. So to fix this, here's what we're going to need to do. We're going to need to multiply this by 3, making this a 6, and then you're going to need to multiply this whole thing by 2. Remember, because you can't put a 2 here because the oxygen is attached to the iron. So you need to put a 2 here, multiplying this by 2, also multiplying this by 2, making this 4 and this 6. So now the oxygen is all good, it's balanced. But it looks like our iron is unbalanced again. So to fix this, we need to erase this 2. And we need to replace this with 4. Therefore, and then this would create 4 irons. So now this would be considered a balanced chemical equation. And then, now moving on to a more moderate problem. This will be a little tougher. We'll do Al plus HCl creates AlCl3 plus H2. To balance this chemical equation, we're going to divide this in half again. We're going to write what we have. So now we have 3 atoms on the left side, and we'll have the 3 atoms on the right side. Okay, looks like we have more of one atom on the right side than we do on the left side. So to fix this, let's start on the left side. Looks like the aluminums are balanced. And let me switch these actually. So this isn't confusing, it all lines up. So to fix this, looks like we're gonna have to mess with the hydrochloric acid on the left side. So looks like chloride is 3 on the right side and hydrogen's 2. So if we multiplied this by 2, we would have only 2 chlorides, but the hydrogens would be good. So that can't be right. So we have to find a common fraction or a common denominator of both of those in order to balance it. And I think the most common denominator in this example will be a 6, giving us 6 hydrogens and 6 chlorides. And then on the right side, we're going to have to fix that. So on this side, chloride here is 3, so we're going to have to multiply this whole thing by 2, giving us 2 AlCl3, which will multiply the Cl by 2, giving us 6, and the Al by 2, giving us 2. And then we're also going to have to fix the hydrogens, putting the 3 on this hydrogen, giving us 6 hydrogens. So now the chloride and the hydrogen are all balanced. Now we have to fix aluminum because now there's 2 aluminums on the right side and only 1 on the left side. So to fix this, we'll just multiply this by 2, giving us 2 aluminums. And that will be your balanced chemical. Let me write this out for you guys. This will be your balanced chemical equation. Moving on to the last problem of the night. This will be a little harder, but should be doable nonetheless. So we'll have OH2 plus H3PO4 creates Ca3PO4 PO4 plus H2O. Once again, we'll divide this in half and write down what we have on each side. So on the left side, we have calcium, we have oxygen, in which we'll have 2 oxygens here, and we'll have 4 there, so that'll be 6 oxygens. And then we'll look at hydrogen, and we'll say, okay, we have 2 hydrogens there, and we have 3 there, so that'll be 5 hydrogens, and we'll have only 1 phosphate. And a good rule of thumb is to only work with, you should start with things that aren't the oxygens and the hydrogens first, because those are typically seen in a lot of chemical reactions in multiple kind of molecules or compounds. So you want to start with your calcium and your phosphate first. And then we'll just also write what we have on this side. And then something kind of similar to point out here is this 2 will actually multiply to the phosphate and the oxygen, creating So we'll have oxygen, and we'll have 8 oxygens, and then, or we'll have 9 oxygens, because we got to remember about this guy. So 9 oxygens, and then in terms of hydrogens, we'll have 2 hydrogens, and then phosphates, we'll have 2 phosphates. So to balance this, let's start with the calcium. So on the right side, we immediately see we have 3. So on the left side, we have to multiply this by 3. To do this, we've got to put a 3 right here. So this will give us 3. That also affects the oxygens, which will be multiplied by 3, giving us so it'll give us 6 oxygens right here, and that doesn't affect those oxygens though. So we'll just wait on this. So we'll just say 6 plus 4 right now gives us 10. And then it also affects the hydrogens, giving us 6 hydrogens right here. So it'll do 6 plus 3 for now, giving us 9. And then we'll have 1 phosphate still. And then it looks like we have 2 phosphates on the right side, so we'll need to fix the phosphates on the left side. To do this, we'll just multiply this whole thing by 2, and that affects the phosphate right there. So times 2 gives us 2, and then we have to affect the hydrogens, which will give us 6 hydrogens right there, and it'll give us 8 oxygens right there. Since you do 2 times 4 is 8, and then 2 times 3 is 6. And that's just how, kind of a good strategy that I like to do. And then, so since this was these 2 were our parts for this, we need to affect these 2. So we'll go ahead and erase these 2 numbers and replace them with the values we got from here. So it was 6 hydrogens and it was 8 oxygens, giving us a total of 14 oxygens and 12 hydrogens. Now on the right side, looks like we're going to have to do some math as well. So in order to change the oxygens and hydrogens, I would recommend starting with the hydrogens first, because there's an H2O over here, which affects both hydrogens and oxygen. So to do this, we're going to go ahead and do 6 H2O in order to get this hydrogen up to 12, and that'll make 6 O's over here, because we also have O over here. So that's why I'm not changing anything right here. And then, so that would be 8 plus 6 so far. But now we have to affect the other oxygen, because right now it's it is at 14. And that'll actually give us the correct chemical equation, being 3CaOH2 plus 2H3PO4, creating calcium 3PO4 2 plus 6 H2O. And that will be your balanced chemical reaction. Thanks for watching, guys. Hope you enjoyed this video. Let me know if you have any other questions, and feel free to drop questions in the comments, and just go ahead and like it. It helps me out quite a bit, and subscribe if you enjoyed. And I'll be posting videos, 2 videos a week on Mondays and Wednesdays. But yeah, thank you guys so much for watching, and I hope you enjoyed.